AB Calculus Notecard 43, go from a graph of f prime of x to a graph of f of x. This is the 43rd video lesson in the series inspired by Stacy McMullen, formerly of the Dallas Independent School District, who developed this notecard system. And she calls this going from f prime to f bazab, backwards, zeros, above and below. Backwards, if we're going from a graph of f prime or f double prime back to the graph of f. Zeros is basically using a number line on the graph of f prime of x, and above or below, above you're going to be putting either a plus sign for where f prime is greater than 0 and a negative sign where f prime is below the 0 line or less than 0. And then it doesn't mention here as a step, but I'm also going to take the f double prime function and look for points of inflection and weave them into the construction of the graph. And the first one we're going to look at is this one. For 1 and 2, sketch f of x on the same coordinate plane. And what I'm going to do is make a little room here just so I can draw number lines. Okay, here we go. There, we shrink that graph just a little bit. And what I'm going to do is we're going to use the same analysis tools that we've used earlier in the last several videos. Particularly, this is really curve sketching. This relationship between f prime, and f double prime. Okay, we look at plus, minus, increasing, decreasing, and concave up, concave down. And then f prime is going to be plus where f is increasing, minus or negative where f is decreasing. And then I'm going to put the arrows up and down here. And finally, for f double prime, we're going to put the plus sign below where there's a concave up curve and a minus sign below where there's a concave down. So that's the relationship we're going to look for. Okay, the first thing I'm going to do is draw a number line, and we're going to draw it on the same coordinate plane, but I'm going to evaluate just where this is. And I'm going to put f prime above and f below right here. And then where the function is 0, where f prime is 0, I'm just going to mark on this number line. So we have -2, 0, and at x equals 2. These are the critical numbers I've just put below the number line. And to the left of -2, we can see our graph is above the x-axis. So we're going to put a plus sign here. And then between -2 and 0, our graph is below the x-axis. And between 0 and +2, we have a negative sign because f prime is below the x-axis. And greater than 2, we are above the x-axis again, so we put a plus sign here. And so the function, the graph of the function f, is going to behave like this: up between -infinity to -2, decreasing between -2 and 0, and still increasing after 0, and then increasing after 2. And so that's that. Now we're going to do the f double prime. So here's f double prime, which has to do with concavity. So we're going to make use of this relationship here. And basically, what we're looking for in a graph of f prime is where the graph of the function is changing from increasing to decreasing, or from decreasing to increasing. That's where we're going to see that f double prime being positive and negative, and hence concave up, concave down. And we change from right here, these are points of inflection. So this is going to be negative, I don't know, 1.5, we'll say. And then we have another point of inflection where f prime is changing from increasing to decreasing at 0. And then a third point of inflection down here at x equals approximately 1.5, where f prime is changing from decreasing to increasing. And so where f double prime is, where f prime is decreasing, right here, we put a negative sign because our function, underlying function, is concave down. Between negative 1.5 and 0, f prime is increasing, so that's going to be a positive concavity, concave up. And then between 0 and 1.5, f prime is decreasing again, so we are concave down on this interval. And then greater than 1.5, f prime is increasing, so the function is, the graph of the function f is concave up. And we're also going to make use of this little sketch like we did before for curve sketching and elsewhere, where if you have f prime is, the graph function is going down, so we have negative, and we are concave down, so that's going to be decreasing and concave down. In the lower right, we're going to be increasing and concave up. The lower left, we're going to be decreasing and concave up. And the upper left, we are increasing and concave down. Okay? So these are the pieces of graph that the thing is going to look like. Okay, says sketch on the same coordinate plane. Again, if you have an original function, it could be anywhere vertically, unless you're given a point to start with. You can do this right along the x-axis. Sometimes I like to go up one, and the reason for that is it might be a little bit less confusing. So between negative infinity to negative 2, we have positive, negative. See, f prime is positive, yet we're concave down. So the positive negative piece looks like this piece right here. So we're going to draw all the way to negative 2 a piece that looks like this. Okay? So there we have that. Next, to the right of negative 2, and negative 2, between negative 2 and negative 1.5, we have a negative, negative. And where does negative, negative look like? This thing right here. And we're going to go all the way to negative 1.5, right? So all the way to negative 1.5. So we're going to go something like this. Okay? So there's that piece. Now from negative 1.5 to 0, we're going to be negative, like decreasing, concavity positive. So minus plus. So it'll be this looking piece right here. So all the way to 0. So here we go. We're concave up, so all the way to 0, something like this. Okay? And then, after 0, we have negative, negative. We're going to be concave down and decreasing, so it's going to be this piece again. And we're going to be doing that all the way to 1.5. So here we are, all the way to 1.5. Okay, that'll look like that. And then between 1.5 and 2, we are negative, positive. So negative, positive looks like this piece here in the lower left. So we take that piece here like this to all the way to 2. And then from 2 on, we're positive, positive, which looks like this piece here. So So that's it. That is the sketch of the graph of f of x on the same coordinate plane using these tools we've been developing over time. Next, problem 2. I'm going to shrink this a little bit too, give more room for sketching. Okay, we have a graph of f prime of x. So, get the skinny line here. So, I'm just going to draw this real quickly. F prime, F double prime without a lot of explanation. Okay, plus, minus, increasing, decreasing, concave up, concave down, plus, minus, increasing, decreasing, and then plus, minus. And then our circle for our pieces here. Okay, minus, minus, plus, plus, minus, plus, and plus, minus. Okay, again, we're going to draw this f prime, and f goes below here. And our only critical number we have here, where f prime is 0, is right here about 1.7, we'll say. And to the left of 1.7, we are below the x-axis, so that's going to be f prime is negative. So the graph of the original function f is decreasing over that interval. And then to the right of 1.7, we've gone above the x-axis, so we have positive. So the function is going to be decreasing over this interval here and increasing to the right of 1.7. Next, we're going to take f double prime over f and get our points of inflection. Well, we have a point of inflection where f prime changes from increasing and decreasing a little to the left of the y-axis. So I'm going to call that maybe negative 0.3. Let's say negative 0.3. That's just an estimate. And then also here, about 1.3, we'll call it. And then f prime is increasing to the left of x equals 0.3, and so that's going to be concave up over this interval, and then between x equals negative 0.3 to x equals 1.3, f prime is decreasing, so the graph of the function can be concave down over that interval. And then finally, between 1.3 to the right, we have f prime increasing, so we're going to be concave up on this interval. And it looks like we're going to be decreasing for a big range of this function here, all the way from the left to 1.7. So I want to start way up here someplace in the upper left. Okay. So the first piece, we have negative, positive, and so we look at our little tool here, we're going to have this lower left piece like this. And so I guess we could assume we're coming from negative infinity, but we're going all the way to 0.3. Okay, so here, I'm gonna come to right here. So we're coming down like this. Okay, there's the first piece. Now between negative 0.3 to 1.3, we're negative negative. So here's our negative negative right here, the upper right, and we're going all the way to 1.3. So I'm going to just kind of visualize, I'll say right here. We'll come right to this point. So we're negative negative, so we're looking like this. Let me see if I can get a little bit better looking piece. Yeah, it's a little better. Okay. There's our negative negative. To the right of 1.3, we are very briefly, until 1.7, negative positive. So what does negative positive look like? This piece again here, similar to the first one we drew. So we're just going to 1.7, which would be about right here. So we're just making this little piece like this. Okay. Then finally, we are positive positive to the right of 1.7 right here. So we're going to be, that's going to be this thing here. So there we go. So this is going to be the graph of our function using, starting from the f prime function and going forward. Again, it's really building upon the skills we've been developing all along. I hope this has been helpful to you. Good luck, and thanks for viewing.